Hi everyone, in this video we will cover part 1, chapter 1 to 10, focusing on the key concepts you need to know before your exam. Starting from chapter 1. For chapter 1, what are the key concepts you need to remember? First is about diffusion because most of the questions come related to the diffusion in the exam. So the first thing is that you have to remember that diffusion only takes place in liquids and gases, not in solids. And in liquids, the diffusion is slower, whereas in gases, it is faster. Second thing you need to remember about the diffusion is that molar mass of any gas is inversely proportional to diffusion rate. What does it mean? It means that if higher the molar mass of any gas, it will diffuse slower. Okay, these are the two main concepts that you have to remember from the chapter 1 states of matter. Let's come towards chapter 2 atomic structure. Chapter 2 atomic structure, the first concept you need to remember that in a neutral atom the proton number is always equal to electron numbers. Second thing is about electron arrangement in the shells. The first shell always carry 2 electrons, whereas in second shell we have 8 electrons that can maximum we can have, okay? And in the third shell the maximum electrons that can be present are 18, but up till 1 to 20 elements you can see that there are only 8 electrons in the third shell. After 20, the 21st element will have different number of the electrons in the shells, which you will see if you will do, but it will not be a part of your exam in the IGCSE. Okay, so let's see about the third concept, that is about isotopes. For isotopes, you need to remember that they are the atoms of the same element. So what does it mean? That they have the same proton number. Their proton number will never change. Only the difference is in the neutron number. That's why different isotopes of the same element will have different mass. Okay, the mass will be different. Why? Because the proton number is same, but neutron number is different. Okay, so because the neutron number is different, that's why their physical properties will be different, because their mass is different. So their density, their radioactivity, or melting or boiling points, they can be different, but their chemical properties will remain the same. Why chemical properties remain the same? Because the chemical properties depends on the electron number, and electron number always equal to the proton number, and in isotopes the proton number never change, it remains the same. Okay, so chemical properties always depend on the electron numbers. The fourth concept you need to remember in this chapter is relative atomic mass formula. You must have to remember this one, because at least one question comes related to the relative atomic mass in the exam. So what is relative atomic mass? It's equal to the abundance, percentage abundance, which will be given in the exam, into the mass. Okay, so you have to calculate by calculating the percentage abundance into mass A. Mass A can be any isotope, and then mass B can be the second isotope, and then you have to divide by 100. Okay, so you can calculate. Sometimes they can give you 3 isotopes also. So you have to just divide the multiply them with the percentage abundance with their given mass, and it will already be given in the exam. Okay, so and remember that the average mass of all the isotopes is always compared to carbon 12. So in exam, if they ask you that which atom it is compared to, it is always carbon 12. Let's see the concepts related to now chapter 3, chemical bonding. So in chemical bonding chapter, you need to remember the three most important chemical bonds, that are ionic bond, covalent bond, and metallic bond. Ionic bond, you need to remember that it's always between a metal and non-metal. Whenever they give you any compound and they ask you which bond is this one, you have to first see that this compound contains either only non-metals or metal or non-metal together. If there is one metal and one non-metal, then it means it's an ionic bond. But if it only contains the non-metals, then it means it's a covalent bond. An ionic bond, or electrons are always transferred from the positive, that is a metal, to the non-metal. Whereas in covalent bond, electrons are usually shared between the atoms, between two different types of the atoms, or maybe of the same atoms of the element. For example, Cl2. Okay, they share the electrons. Electrons are shared between both the chlorine atoms, that is the molecule. Third thing is metallic bond. In metallic bonds, the metal will lose their electrons. So metallic bonding is usually between the elements. All the metal elements, they have the metallic bond. And this metallic bond is formed between the positive ions of the metals and their electrons, which they are the delocalized electrons from their last shells. Okay, so how the metallic bond is formed? It's formed between the positive ions in a sea of delocalized electrons. Let's see some properties of these compounds. So if we have ionic compounds, their melting and boiling will always be higher, and they are giant ionic structures. Okay, they are always giant structures, and they have a very high melting and boiling point. What about the electrical conductivity? The electrical conductivity of ionic compounds, they can only conduct electricity when they are in the molten state or in the aqueous state, because for electrical conductivity, there are two things that are important. Either you should have free ions or you have delocalized electrons. So in ionic compounds, they have free ions only when they are in the molten form or in the aqueous solution. But when they are in the solid form, they are very compact and they are very close together. They are not free. So free ions are not free. That's why the ionic compounds cannot conduct electricity when they are in the solid form. Okay. What about the solubility? Ionic compounds are usually soluble in the water. Most of them, 99% of them, are soluble in water. Let's see about the melting and boiling points of covalent. So we have two types of covalent compounds. Either they can be simple, which are like, or the giant structures. Okay, simple molecules, for example, water, carbon dioxide, they all are simple covalent compounds. They have low melting and boiling points. They have no electrical conductivity. They are very good insulators. And solubility, they can dissolve in inorganic solvents, but not in water. What about giant covalent structures? Giant covalent structures have a very high melting and boiling points. For example, diamond, graphite, or silicon dioxide. What about the electrical conductivity? They are also very good insulators. They do not conduct electricity except for the graphite. Graphite can conduct electricity because it has free electrons, or you can say delocalized electrons. That's why graphite is only the exceptional case in covalent bonding that can conduct electricity. That's why it is also used as an electrode. Let's see about the solubility. Giant covalent structures are usually insoluble in any of the solvents. Let's come towards the metallic. Metallic compounds are not, usually metallic compounds is not a right term. It's metallic elements, because elements have a metallic bond. So we can say that elements, usually the metal elements, form the metallic bond. So metallic elements have a high melting and boiling points. They have a very high electrical conductivity because they have delocalized electrons in their structure. So even in the solid form or in the molten form, they can have their electrical conductivity. What about the solubility? In water, they are insoluble in water, but they can react with the water. So whenever you add sodium in the water, it will not dissolve in the water, but rather it will just react with the water and give you the different products. Okay, so these are the some of the properties of the ionic, covalent, and giant covalent and metallic structures. Let's come towards chapter number 4, chemical formula and equations. So before you write any chemical formula or equations, you need to remember some of the key concept, that what is oxidation state, because actually oxidation state will help you to design the formula in the exam. So oxidation state is actually the group number, the group 1 to 4. Oxidation state is the actually ability of an element to lose an electron or to gain an electron. So all the elements that are present in group 1 to 4, their oxidation number will be same like their group number. For example, you can see here magnesium, it belongs to group 2, so its oxidation state is 2 plus. It means it can lose 2 electrons. If it has a positive charge, it means it is able to lose 2 electrons. What about the oxidation state of elements in group 5 to 8? The group 5 to 8, you can calculate their oxidation state by 8 minus group number, and usually their oxidation state is in negative. What does it mean? It means they will usually gain the electrons, because it is more suitable for them to gain electrons rather than to lose electrons, because it is easy to gain the electrons. For example, chlorine belongs to group 7, so its oxidation state is 8 minus 7, that is 1. So but the negative charge will come because it will gain 1 electron. Okay, so this is how you calculate the oxidation states of different elements in a different group number. And there are some important polyatomic ions and their oxidation state that will help you to make the formula, so you have to remember their oxidation states. Sulfate ions. Sulfate ions is a polyatomic ion because it has two different types of the elements, sulfur and oxygen. So it usually have a 2 negative charge. Okay, sulfate ions. Then you have ammonium ion, and ammonium ion has a +1 charge. Hydroxide ion -1 charge. Carbonate has 2 negative charge. Phosphate has 3 minus charge, and nitrate has 1 minus charge. You have to remember these 6 polyatomic ions because they are the most common polyatomic ions that you will see in your exam. Number 4. Okay, you have to remember the state symbol for the equations, and for water it is always the same, that is L. The state symbol for water will always be L. It will never be AQ or any other. So whenever they ask you for the state symbol, you have to first see for the water. If water is there, it should be L. And for the acid and alkalis, all the acid and alkalis, it is always AQ. The state symbol that you have to remember, that for acid and alkalis, it will always be AQ. Okay, and also for the ions, if you see the ions in the product, then ions will also have AQ as a state symbol. Okay, so these are some of the concepts that are related to chapter 4. Now let's see chapter 5, chemical calculations. Chapter 5 is related to chemical calculations, so you have to remember some of the key concepts related to those calculations. First is the Avogadro's constant. Avogadro's constant, you need to remember the what is the number of that you have to remember. It is 6.02 into 10 raised to power 23 particles and per mole. In 1 mole, usually the Avogadro's constant is 6.02 into 10 raised to power 23. For example, if someone asks you in the exam, 1 mole of water has how many molecules? So it means 1 mole of water has 6.02 into 10 raised to power 23 molecules. But if they ask you about the atoms, then you have to count the number of the atoms. It will remain the same. Can you see here that 6.02 into 10 raised to power 23 atoms? But because the number of the atoms is 3, so you have to write 3 into 6.02 into 10 raised to power 23. I hope this is clear to you. So be very careful when the question they are asking about the molecule or the atom. Okay, if they are asking you about the atom, so you have to look at that molecule, that how many atoms are present in 1 mole. And the second thing is about you have to remember the 3 mole formula for the calculations, because from chapter 5 at least 2 or 3 questions will come that will be related to the mole calculations. And for that you have to remember these three formulas. First, for the solid, if you see some gram information in your question, then it means you have to use this formula. Moles is equal to mass in given divided by molar mass. This molar mass you have to find it from the periodic table, and this one usually will be given to you in the question paper, or sometime they will give you the moles and you have to calculate the mass given. Let's see for the second definition of solutions. Moles is equal to concentration into volume. Usually the question will have the volume information, or maybe they will be giving you concentration, or they will be talking about some solutions. So if you see the word concentration in a question or volume, then you have to use this formula, okay, for solving your question. And the third one is for gases at room temperature. If there is any concept in the question is related to the gases and they are asking about the volume of the gas, then you have to use this formula. Moles is equal to volume divided by 24 dm cube, because 1 mole of a gas at room temperature, standard room temperature and pressure, always have a volume of 24 dm cube. Okay, I hope this is clear to you. Now another formula that is very important, and it usually comes in the paper too, is to calculate the percentage yield. So you have to remember the percentage yield, that is equal to actual yield divided by theoretical yield into 100. What is theoretical yield? Actually, it's already I have given you. Theoretical yield is the mass given, the given mass you have to find using this formula. Moles is equal to given mass divided by molar mass. So this is the theoretical yield, and the actual yield will always be given to you in your question. You never know about the actual yield, because if an experiment is performed, then you can know that how much yield you get, right? So this yield, actual yield, will be given to you in the question paper already. So you have to find only the theoretical yield. And how you can find? The formula I have already given you, that is the moles formula for the solid masses. Okay, so you can use this formula. Let's see chapter 6, electrochemistry. So electrochemistry, some of the concepts are very important and you have to remember, then you will never lose marks. The questions related to electrochemistry about the products that you can get at the anode or the cathode. Usually the student do the mistakes when they have to find the product at the anode or the cathode. Okay, so these are some of the concepts you need to remember. First is ions move through the electrolyte. So in exam, if they say that ions move through the external circuit or electrons move through the electrolyte, then that is a wrong statement. Only ions can move through the electrolytes, right? And the second thing, electrons always move in external circuit. They never move in the electrolyte. So if you see this option, it is always wrong. It's the right option is electrons always move in the external circuit. And from where to where? From anode towards cathode. So towards cathode is always a right option. So if you see the arrow of the electrons moving towards cathode, that is the always a right option. Another important thing for to remember the products, you have to remember these three things: molten electrolytes, dilute aqueous electrolytes, and concentrated aqueous electrolytes. So if you see the molten electrolyte, then you don't need to worry about the product, because the product will be same like your electrolyte. Okay, so the cations will move towards the cathode, that is a positive ion. Okay, so for example, in the molten NaCl, the product at the cathode will be sodium, whereas the anode, a negative ion will move, that is called anion, will move towards the anode. So you will get chlorine gas at the anode if it is a molten. Okay, so you will get your own ions from the same compound. But if you have dilute aqueous electrolytes, so for dilute you need to, for aqueous, especially for aqueous, you need to remember, if the electrolyte is aqueous, you will always get at the cathode hydrogen gas. Okay, and if it is dilute, then you will also get oxygen at the anode. Okay, you will not get NaCl, any Na, sodium or chlorine, you will not get at the anode or cathode. You will only get hydrogen gas at the cathode, because it's an aqueous electrolyte. And if it is dilute, then at the anode you will get oxygen. But if you have concentrated aqueous electrolyte, for example we have concentrated NaCl, then I already have told you that in aqueous we will get always hydrogen at the cathode. But now if we have concentrated, then in concentrated at the anode you will get your anion, that is chlorine gas. Okay, so you will get your own anion which is in that solution, so that is chlorine. So you will get the chlorine at the anode, but not the oxygen, because now it is concentrated. Okay, but if it is dilute, then you will get oxygen. I hope this is clear to you. But now we have some exceptional case, that is in term of copper. Mostly in exam they ask you about the copper salt solutions. These are the exceptional cases. For copper salt solution, you have to see two things. First, you have to look at the electrolyte, that it's copper. Okay, and the second thing, you also have to look at the electrodes. If the electrodes are carbon, inert, or platinum electrodes, then and you have a solution like dilute copper sulfate and copper chloride, okay, aqueous solution. So copper, you will never, whenever there is a copper, you will never get at the cathode the hydrogen gas. You will always get copper. So this is, you have to remember, whenever you see copper, even if it is a dilute solution, it is a concentrated solution, you will always get copper at the cathode, not hydrogen. But because anode depends on dilute or concentrated, so it will remain the same. Okay, dilute, if the solution is dilute, then you will get oxygen at the anode. But if the solution is not dilute, it is concentrated, so then you will get your own anion. And that is, for example, in copper chloride, you will get chlorine at the anode. But if it is sulfate, then of course, again, you will get oxygen, not the sulfate ion. Why? Because sulfate ion, even if the solution is concentrated or dilute, it will never, it is very difficult for it to move towards the anode. Okay, so that's why or oxidize. Okay, sulfate ions, it's very difficult for them to oxidize. So that's why even if there is a concentrated solution or dilute solutions in copper sulfate, you will always get oxygen at the anode and copper at the cathode. Okay, but if there is copper chloride, then you can get copper at the cathode, copper will remain the same, and at the anode you will always get oxygen or chlorine. Okay, it depends. If you have SO4 copper sulfate, you will get oxygen, and if you have a chloride, then you will get chlorine as a gas at the anode. Okay, this is for the electrodes if they are inert. So it means even if it's inert electrode, it is like at the cathode you will always getting copper. Okay, only now the anode answer will change. But let's see about the copper electrodes. If you are using the copper electrodes, then what will happen? If the solution is dilute copper sulfate or copper chloride, you will always get copper at the cathode. Okay, so now it is clear that even if you are using inert electrodes or you are using copper electrodes, cathode product will always be same, that is copper. Okay, so whenever you see the copper and they ask you about your cathode product, it is always copper, even if they are using the copper electrodes or even if they are using the inert electrodes or the carbon electrodes. Okay, the cathode, as always, the product is copper. But now let's come towards, if you are using copper electrodes, what will be the product at the anode? So at the anode, the copper, even if you are using dilute solution or you are using concentrated solution, everything, you will never get the chlorine or oxygen. You will always get copper ions. Why copper ions? Because the anode is made up of copper and it will start oxidizing itself. So that's why you will get here, always you will get the copper ions. Okay, so if you are using the copper electrode, then it will always be copper ions at the anode, because the copper electrode, anode electrode, will start oxidizing itself and it will change from copper metal to copper ions. Okay, I hope this is clear to you. So now let's repeat again. If we are using copper sulfate, okay, and we have inert copper sulfate, and what will be the product? Even if we are using platinum electrodes or copper electrodes, in both the cases we will get copper at the cathode. You can see copper at the cathode, right? But if you are using copper electrodes, then at the anode you will get copper ions, even the solution is dilute or concentrated. Here my mistake, it's concentrated. Okay, so you will get copper ions. But if you are using the inert electrodes, then at anode you will get oxygen if the solution is dilute, and if it is concentrated, then you can get the, if for example it's chloride ion, then you can get chlorine gas. Okay, the concentrated will give you your own anion in that compound. So these are the main concept that you have to remember related to chapter 6. Chapter 7. Now let's come toward chapter 7, chemical energetics. First of all, you need to remember the difference between exothermic and endothermic reactions. Exothermic means that it will release the heat to the surrounding. Exo from exit. So the heat will be releases to the surrounding. So when the heat will release, so temperature will always increase. So in exam, if you see the word temperature, even if they are all talking about the solution, that the temperature of the solution, don't get confused. The temperature will always increase for exothermic reaction, even if there is a word solution there. Okay, and the some of the example of exothermic reactions are combustion, neutralization, and respiration. These are the examples of the exothermic reaction. Endothermic, they usually absorb the heat from the surrounding, so the temperature of the surrounding will decrease. So temperature, if they say in the question that the temperature of the solution decrease, then it means that it is endothermic. Don't get confused with exothermic, that okay, it release the heat, so that's why maybe the solution is now the temperature has decreased. No, temperature will always decrease for the solution also in endothermic. Why? Because all the heat is given to the reaction and you cannot see the heat of the reaction. Okay, you can only feel the temperature, that is actually for the surrounding. So solution is also your surrounding. These are some of the examples of the endothermic reaction: photosynthesis and thermal decomposition. Okay, again I will repeat, whenever you see the word temperature, even if they are talking about water or they are talking about the reactant temperature, still it is temperature. If it is decreasing or the reactant temperature is decreasing, still it is an endothermic reaction. You have to just remember, you have to just see the word temperature. Temperature means they are talking about surrounding. Okay, even if they use the word reactant, they use the word solution or the beaker, anything, temperature is the word that is used for the surrounding. Okay, let's see now energy profile diagrams. Usually when you see the energy profile diagram, sometimes the students get confused in exothermic and endothermic reactions. You need to remember, in energy profile diagrams for exothermic reaction, the products are always at the lower energy level. Why at the lower energy level? Because the reactants already have given out all the heat. So reactants were at the top energy level, and when they gave out all the heat, now your product will be at the lower energy level. That's why in the energy profile diagrams, products are always at the lower energy level. Okay, and delta H, enthalpy change, is always negative. If you see a negative sign with the delta H, it means it's an exothermic reaction. For endothermic reaction, the products are always at a higher energy level. Why? Because reactants have a very low energy level and they gain the heat from the surrounding. So when they gain the heat from the surrounding, the product they will give you, they will be at the higher energy level. And that's why delta H is positive, because all the heat has been absorbed. So the heat of the reaction is actually positive. So delta H is positive for endothermic reactions. Let's about when you are calculating the bond energies, you need to remember that bond breaking is an endothermic reaction. So whenever you are calculating the bond energies for the reactants, it means that is endothermic. And for the products, it's always exothermic, because new products, new bonds are formed. So that is an exothermic reaction. And whenever you are calculating the enthalpy change, then first you have to calculate the endothermic, that is bond breaking in the reactants. Okay, the bond breaking in reactants, and then you have to minus that one with the total energy of the bond making in the products. I hope this is clear to you. So delta H is equal to total energy to break the bonds minus total energy to form the bonds. Okay, these are the main concept related to chapter 7. Now let's see chapter 8, rates of the reaction. So for rate of reaction, you have to remember that there are five main factors that can affect the rate of the reaction. First of all, concentration. So concentration of any solution can affect the rate of reaction. If you have solution or some liquid, then higher the concentration means higher the rate of reaction. Why higher the rate of reaction? Because there will be more chances of collision. We have more number of particles. It means more number of particles. So more number of particles means there are more chances of collision. So when there are more chance of collision means the more successful collisions chances are now increased. Okay, more collision means more successful collisions also have been increased now. Let's see about temperature. So higher the temperature, higher will be the rate of reaction. Why higher the rate of reaction? Because once the temperature is higher, there will be more kinetic energy to the particles. So the particles will move faster, because kinetic energy is related to the movement. So more kinetic energy means the particles will move faster, so they will collide more often. And when they will collide more often, it means the more successful collisions. That's why temperature also have a positive effect on the rate of reaction. Higher the temperature, higher will be the rate of reaction. Third is surface area. Surface area means it's mainly for the solid. If your reactants are solid, then the more the surface area, it means the more there will be chances of the collision. So more surface area means higher the surface area means the smaller the particle size. So higher surface area means there will be high rate of reaction. And high surface area is always for the small particles or maybe the powdered formed. Okay, so the large particles have a small surface area. The large particle, for example, this is a large particle, so its surface area will be smaller. But if the same one, if I make the small, I make it a small particle, then you will see that it is actually, it will take more space. Okay, so it means the surface area will become more. So that's why the smaller the surface area means the bigger the particles are, and smaller the particles are means this more the surface area. So surface area, if it is more, then there will be more chances of collision and the rate of reaction will increase. So it means smaller particles increase the rate of reaction. Let's see for the pressure. Pressure is only for the gases. If your reactants and products are gases, then pressure can affect the rate of reaction. Higher the pressure, higher will be the rate of reaction. And the reason is because the particles will have now less space. So higher the pressure, the particles will have now less space, so they will collide more often. Fifth is the catalyst. How the catalyst will affect? Catalyst will affect the rate of reaction. It will increase the rate of reaction by lowering the activation energy of the reaction. It has nothing to do with the particles. It will not increase the speed of the particles. It will not increase the kinetic energy of the particles. Even it will not increase the chances of collision. Only the things it will do is lower the activation energy of the particles. So when the lower the activation energy of the reaction, lower the activation energy of the reactants. So once the lower the activation energy of the reaction. So once the activation energy of the reaction is lower, what will happen when the particles will collide with each other? They will have more chances of successful collision. Before, if they need the activation energy greater than 130, so after adding a catalyst, it will be less than 130. So all those particles that are colliding with less energy than 130, they can still have successful collision. Okay, so that's how catalyst can increase the rate of reaction. Okay, now let's see an important concept, collision theory in chapter 8. According to the collision theory, reaction happens when particles collide with enough energy. So there are two things that are important in the for a reaction to take place. First, collision, that particles must collide, and the second thing is that with enough energy. If they don't have enough energy and they collide, they will not give you a product. So you will not get a product if there is only collision but not enough energy. So what is that energy? It is actually the energy that is equal or maybe greater than the activation energy, and every reaction has different reactions have different activation energy. Okay, so it is different for all the reactions. It's not always the same. Second thing is high temperature, high pressure, and concentration will result in more frequent and energetic collision. That's why the rate of the reaction will always increase by increasing the temperature, pressure, or concentration. Another thing is measuring the rate, the practical methods, how we can measure the rate of the reaction. Mostly in the exam, when they will give you some question, they will be asking about the loss in the mass. Loss in the mass is the only possible when you are doing a reaction when a gas is formed in a product. For example, if they want to measure the loss in a mass on a balance scale, how they will know? If the product is not a gas, then everything will be here. But if it has a gas and the gas will evaporate out from the solution, you will see the change in the weight. Okay, change in the weight of the reactants or your product. Okay, so that's why how you can measure the rate of the reaction. You can measure the rate of the reaction either by measuring the loss in the mass if you have a gas in the product. Okay, it's only possible if you have a gas in the product. If you don't have any gas in the product, then this method is not suitable. Second is the volume of a gas collected. You can also do another method by measuring the volume of a gas, but then you have to close this beaker because so that no gas can go out, and you can use a syringe over here to measure the volume of a gas. This is another method that is used to measure the volume of a gas. And when you measure the volume of gas, you can also measure the rate of reaction. How? With the time, that how much time it is taking to get the specific volume of a gas. Okay, so you can do two different experiments, and if you are using a high temperature, you can see that okay, at high temperature how much gas has been collected in 20 minutes maybe, and if you are using the room temperature, how much gas has been collected in 20 minutes. Okay, so the difference will tell you that okay, high temperature will give you in 20 minutes you will get more gas as compared to the room temperature. So this is how you can calculate the volume of a gas when you are comparing the rate of reaction. The third is the another method is, rather than measuring the product, you can also measure the reactants. Sometimes your solid you can also see your reactants. For example, if they are the precipitate and you are dissolving it in a solution, so you can also measure the time, that how much time it has taken for that specific solid to dissolve or to react with that solution. Okay, when the solid disappears, it means your reaction has stopped, right? So it can also help you to measure the rate of reaction. So this is also another method. Another method, one fourth, another method is also that the formation of the precipitates. So the time taken to for the formation of the precipitate in your product is also a method to measure the rate of reaction. How you can measure the formation of the precipitate? For example, you can just put a cross here, and then two solutions are mixed together, and a time will come when your product is formed and it has precipitate. So these precipitate will help. Then when they are precipitate at the bottom, you will not be able to see this cross. Okay, so it means your product has been formed and you can measure the rate of the reaction now. So you can also use these four methods to measure the rate of reaction practically you when you want to do. Okay, another thing about the questions that will come in your exam, and they will ask you that, okay, which at which time the rate of reaction is faster, or at which time the rate of the reaction is slower. For example, they give you a speed like this, and they will ask you that, okay, what time 0 to 1, 0, 1, 2, 3, what time the rate of the reaction is faster. So how you will know the rate of the reaction is faster? You have to draw an arrow from here. You see triangle, you can make a triangle, and you can see that how much time it is actually taking now to get that product up till there. So if the steep is slow, that this line is in a slow form and is more steeper, then it means the reaction is faster here. And if you get a straight line, then it means the reaction already has stopped at this place. Okay, straight line means the reaction has finished, it has been stopped. And if you see a steep line, a steep slope, it means that at that time the reaction was the fastest reaction. Okay, I hope these points are clear to you. Now let's see chapter 9. The most important concepts you need to remember in chapter 9 is related to Le Chatelier's principle, that what are the effects of different factors on the equilibrium, right? Because in reversible reactions we have equilibrium, and once the equilibrium is reached, you have to move that reaction either in the forward or in the backward. It depends on you. So if they ask you in the exam that if what will be the change applied to the equilibrium position if there is an increase in temperature. So for that, you have to first look at the reaction, that forward reaction is endothermic or exothermic. If it is endothermic, it means the forward reaction, it will move towards the forward reaction, right? It will move towards the right. So increasing the temperature always favors the endothermic direction. So if your forward reaction is endothermic, it means it will move, the equilibrium will shift towards the forward or the right side. But if your forward reaction is exothermic, then increasing the temperature will helps the backward reaction. Okay, so it means increasing temperature always helps the endothermic reaction direction. So the direction will be towards endothermic if you increase the temperature. But if you decrease the temperature, it will always favors the exothermic reaction. Okay, so your equilibrium will shift towards the exothermic direction. Third is increasing the pressure. If you increase the pressure, it will always shift, the equilibrium will always shift towards the gas molecules that are fewer in moles. Okay, when the number of moles are fewer at that site, the equilibrium will shift. For example, in your products, in your reactants, if you have 2 moles and in your product you have 3 moles, so if you increase the pressure, the reaction will move backward. Okay, it will move towards the left side because the reactants have fewer number of moles. But if you decrease the pressure, the shift will move towards the more number of the gas molecules. So if you decrease the pressure, it will move towards the right direction, towards the product side. So these concepts you have to remember, that what will be the effect of increasing or decreasing the pressure at the equilibrium stage. Another thing is increasing the concentration of a reactant. It's simple. If you increase the concentration of the reactant, it means it will favor the product now, because the equilibrium will start making more products, so that the equilibrium can be reached again. So the system will start making new product. So it will move towards the product if you increase the concentration of a reactant. If you remove the product, then again it will shift towards the right, towards the product, because now the product is less. So the system will try to make more product. So your equilibrium will shift again towards the right to make more products. You have to remember these 6 concepts, and also what will be the response of the system according to these changes. Another thing you have to remember, we know that catalysts actually increase the rate of reaction, and these also factors, increasing temperature, increasing pressure, increasing concentration, also increase the rate of reaction, right? But they can also increase the yield depending on the situation, right? They can also shift the equilibrium. But when it comes to catalyst, it can increase the rate of reaction, but it will never change the equilibrium position, because catalyst will have the same effect on both forward and reverse reaction. If you will add a catalyst, both forward and reverse reaction will be at the same rate again. So the reaction can be faster, but it will not change the position of the equilibrium. You will get your equilibrium faster if you add the catalyst. Okay, it only helps the system to reach the equilibrium faster, but it will not change the position of the equilibrium. It will not help the right side or the left side. Okay, so equilibrium will never shift to left or right because of catalyst. So only there are three main factors that can shift the equilibrium, that is temperature, concentration, and pressure. Let's come toward chapter 10, redox reaction. For this, you have to remember the oxidation and reduction. Okay, what are redox reaction? In which oxidation and reduction is taking place simultaneously. At the same time, oxidation and reduction is taking place. So oxidation, there are three main definitions for oxidation. First is the gain of oxygen. If any element is gaining oxygen, it means it is oxidized. If there is no oxygen involved in that reaction, then you have to look for the electrons or the oxidation number. If you see that the oxidation number has been increased, in the reactant it was less and in the product it is more, now the oxidation number is more, then it means that this reaction is actually this element is actually oxidized. Okay, so this is oxidation. And if you also see the loss of electrons of an element in the reactant, it has more number of electrons, but after that it has in the product it has less number of electrons, then it means it is actually the oxidation. For example, if you see chlorine, we have two chloride ions, and when they lose the electrons, it will get Cl2, right? So, and then two electrons have been given out. So it means this is oxidation. In electrolysis, it is actually oxidation because chloride ions is losing two electrons. So loss of electrons is actually oxidation. No oxygen is involved, so this will be not the, we cannot use this definition for this statement, but we can use this one also, increase in oxidation number. How? If you remember that now here the oxidation number is -1, and here when we have a molecule or we have something is in the form of compound, then oxidation state is always 0. All the covalent compounds or the covalent molecules usually have a 0 oxidation state. So you see -1 is a small number, whereas 0 is a bigger number. So it means the increase in oxidation number. So this is an oxidation process. Okay. Reduction. What is reduction? Reduction is the loss of oxygen. So if anything lose oxygen, it means that element is actually reduced. Okay. And gain of electrons also, if it is gaining electrons, then it is also reduced. And decrease in oxidation number, that is also oxidation, sorry, that is also reduction. For example, if the chlorine is losing two, if it chlorine is gaining electrons, for example, we just write like this. Here we have one chlorine, we have two chlorines, sorry, we can just write like this, and then it gains two electrons, so it will make two chloride ions in an aqueous solution, for example. Then this is reduction. Okay, it is gaining two electrons. Before it has a 0 and now it has -1. So what does it means? The decrease in the oxidation number and gain in electrons, so it is reduction. Okay, so this is how you can see that the redox reaction, if there is a gain of oxygen, loss of electrons, increase in oxidation number, then it is oxidation. If there is loss of oxygen, gain of electrons, and decrease in oxidation number, then it is reduction. Now let's come towards oxidizing and reducing agent. Oxidizing agents, you are always the opposite. Okay, oxidizing agent means actually it is reducing itself, it is reducing. For example, here chlorine is oxidized, right? So here chlorine is actually a reducing agent, not an oxidizing, because itself it is oxidized. So here the chloride ions were actually the reducing agent because itself they are oxidized, but maybe there is another element present in that reaction which is reduced because of this one, right? So itself they are so oxidizing agent, this one is an oxidizing agent. Why? Because itself it is reduced, itself get reduced, but it will cause oxidation of an other element of any other compound. Okay, so it can cause the oxidation of the other element or another atom. That's why it is an oxidizing agent. So if you see the word agent, it means it is the opposite for itself. For itself it will be reducing, and for others actually it is oxidizing. Okay, so it is oxidizing an other element, but itself it is reduced. And same is for the reducing agent. Reducing agent means anything that is itself oxidized, okay, but it is reducing another element. Okay, so all the metals, mostly the metals, because they love to oxidize, so they are usually the reducing agents. Metals are usually reducing agents because they love to oxidize, and non-metals are usually oxidizing agents because itself they used to reduce. So it's they gets reduced themselves and they oxidize the other one. So now let's see oxidation number. The common oxidation number you have to remember is that for in the element form, all the or in the compound form also, the usually they have a zero oxidation state. Okay, so the oxidation state for any molecule in the element form is always zero, and in the ion form it is equal to their charge number. So chlorine, if what is the oxidation state, it will be its charge, that is -1. The charge for sodium, for example, its charge is +1, so it means this is actually its oxidation state. Okay, and same is the sum of the oxidation number in the compound is always zero. So compounds also have the oxidation state zero. That these are the main things you have to remember when you are calculating the or you are doing the redox reactions, or you want to calculate the oxidation number. Okay, how to test the redox reaction? If you want to test the redox reaction, mostly it's asked in the exam. So acidified potassium magnate is used, and if its color change from purple to colorless, what does it means? It means that if the color change from purple to colorless, then it means there is any other reducing agent is present there. Okay, so how we can test for the reducing agent? Because it means that this one is acidified potassium magnate is actually reduced, because itself this one is an oxidizing agent. Potassium magnate is an oxidizing agent. What does it means? Itself it will be reduced and it will oxidize the other one, right? So potassium magnate is actually an oxidizing agent, and if you want to see another solution is a reducing agent or not, then you can add it in the potassium magnate solution, and if there is a change in the color, it means that potassium magnate has been reduced. The reaction is reduction, so you can easily find that okay, the other solution which you don't know that whether it was oxidizing agent or reducing agent, if the color change, it means it was reducing agent because it reduced the acidified potassium magnate, right? So that's why if acidified potassium magnate will be usually reduced in the reaction when it change the color, so that it will be a reduction reaction and it means a reducing agent is present. What about potassium iodide solution? If the potassium iodide solution, actually potassium iodide is a strong reducing agent. What does it mean? It means itself, it will be oxidized, right? So it means if you want to check any other solution and you want to confirm it's an oxidizing agent or a reducing agent, then if you add it in the potassium iodide solution, what will happen? If there is a change in color, the brown color of the potassium if you see the brown color of the potassium iodide, that is because of iodine formation. So then if you see the solution change to brown color, it means your final color is brown. Before it was not, there was no color, and later it changed to brown. So it means that now there is some oxidizing agent present in the solution. Okay, because potassium iodide itself is a reducing agent, so it will be oxidized only by an oxidizing agent, right? So it means an oxidizing agent is present. But if it doesn't change the color and you add the solution, it means that solution is actually not an oxidizing agent. Okay, so this is how you can test the redox reactions also, and you can also confirm that which one is an oxidizing agent and reducing agent, because we already know about them. Acidified potassium magnate is a strong oxidizing agent, and potassium iodide solution is a strong reducing agent. So these are the main concepts that are related to chapter 1 to 10, and you need to remember them. It will be helpful for you to answer the questions in the exams and get full marks. I will do from chapter 11 to 22 later in the second part, but before ending this PPT, I will give you some important chemical processes from the whole book that have conditions, because there are so many chemical reactions that don't have conditions, but there are 10 to 12 important chemical process in your book that have the chemical conditions, and you have to memorize them, because at least one or two questions will come in your exam related to the conditions, that okay, what is the condition for the Haber process, or what is the condition for the context process, or some other conditions they can ask you in the exam. So you have to memorize these conditions, that what are these conditions for each of the reaction. There are only 12, so it will be easy for you to memorize. I have collected them together in this file. So at the end, you can join our WhatsApp channel, and then you can get this in the PDF form. So it will be easy for you to memorize these conditions without looking at your book and finding these conditions or these chemical process. Okay, so you will get them all together in one page. Let's see, the first one is ammonia manufacture. That is also called a Haber process. What are the conditions? The most common conditions are 200 atmospheric pressure, and or you can say if it is in kPa, then you have to multiply with the 100, right? So it can be 20,000 kPa or 200 atm. So be very careful with these units. Okay, if they are asking in kPa, then it will be 20,000, it will not be 200. And then the temperature is always 450, and the iron catalyst is used. This is the example of the ammonia manufacture. Nitrogen is reacting with hydrogen, and then you are getting an ammonia. Second is sulfuric acid manufacture. That is a contact process. It's also in the chapter 9. So conditions are too atmospheric. So the conditions are very low for the pressure. Pressure is low, but the temperature is same like the Haber process, 450. Whereas the catalyst, vanadium oxide. Vanadium oxide is a catalyst that is used for this reaction, and the pressure is just 2 atmospheric pressure. 1 atmospheric pressure is standard, and it is just 2 atmospheric pressure, or you can say 200 kPa. The third one is rusting of iron. This reaction involves, what are the conditions? Oxygen and water. If there is no oxygen and water, the iron will not rust. So iron will only rust in the presence of oxygen and water. That's why when it rains, usually the iron get rusted, because of the water, because of the water drops and the oxygen present in the air. So they will result in the rusting of the iron. The fourth one is cracking of alkanes. Whenever alkanes, the cracking of alkanes, what does it mean? It's the production of small alkanes and alkenes from the alkenes from the alkanes. And we already know what are alkanes. Alkanes are the saturated hydrocarbons. Okay, these are the saturated hydrocarbons from which we can get the alkanes and also alkenes. And in this process, the condition is usually 500 degrees Celsius. So larger alkanes that are more than 20 or 30, they have more than 30 carbons, we can make them shorter, and we can get 2 to 8 carbon molecules from that one. Okay, we can get 2 to 8 carbon alkanes or alkenes from them to the process of cracking. So the cracking actually involves the high temperature. When you give the high temperature in the presence of alumina catalyst or silica, these are the two catalysts. Any catalyst you can write in the exam, you will see. And then what you can get, you can crack this, the bigger molecule of the alkanes, into the smaller one, which you can see over here in the example. So what are the conditions for cracking? It's the high temperature, 500 degrees Celsius, and a catalyst that can be alumina or silica. Fifth, hydrogenation of alkenes. Okay, so these are actually, most of these conditions are from the organic chemistry topic, right? Chapter 18, 19, and 20. So let's see now in 5, hydrogenation of alkenes. Hydrogenation means hydrogen. Okay, hydrogen, addition of hydrogen, not water. If it is hydration, then it is actually the addition of water. But this is hydrogenation, means the addition of the hydrogen to the alkenes. Alkenes are the double bond homologous series of the hydrocarbons. They contain the double bond. This is the functional group of alkenes. So C2H4, for example, ethene, when reacts with the water, you will get what? Ethane. So it is the formation of alkanes from the alkenes. So what are the conditions? There you cannot convert the alkenes into alkanes at room temperature. You have to give a high temperature, that is 150 to 300 degrees Celsius, and a nickel catalyst. In the presence of a nickel catalyst, this alkene can be converted into an alkane. Number 6, another reaction, that is hydration of ethene now. Hydration of ethene, or you can say hydration of alkene. So this is a process that is used to make ethanol industrially. What is the process? You have to give a high temperature, 300 degrees Celsius, 60 to 70 atmospheric pressure, or you can say 6000 kPa, you can convert, and also a catalyst, that is phosphoric acid. So phosphoric acid as a catalyst is used for this reaction. So you have to memorize these things, okay? Don't get confused. You need to remember these catalysts, also the temperature and the pressure. Let's see about fermentation. Fermentation is also a process of making ethanol, but it's not an industrial process. So what are the conditions for fermentation? You can easily get at room temperature. So room temperature 25 to 35 is best to make ethanol. But what is the main important thing that you need to remember? It is fermentation. It's clear from the word that you need a yeast. Okay, the process of fermentation involves the yeast as a biological catalyst. So you must use yeast to convert it into the ethanol, okay, to convert the glucose into ethanol. So making ethanol, fermentation process is the formation through the glucose. So usually glucose is used to convert to make the ethanol. And for ethanol, it's not an industrial process because it's actually a slow process. So we usually use yeast as a to convert the glucose and into ethanol. And how usually we do it at our homes, when you are baking something and you add the yeast powder, actually we are doing the process of fermentation, and this process usually takes place in the absence of oxygen. Remember that this is also the condition. You cannot do this process in the presence of oxygen. So fermentation actually carried at the room temperature with the absence of oxygen and with the addition of the yeast as a biological catalyst. Another important reaction is chlorination of alkane. That is also called substitution reaction, when two hydrogen will be replaced by the, can you see here? It will be replaced by the, one of the hydrogen is replaced by chlorine, and the other hydrogen is actually the one that is replaced will react with the Cl. So you will get HCl, and then you can see over here you will get the CH3Cl. So this reaction only needs UV light. So for chlorination of the alkenes, this is also a this reaction, you use the UV light to start a reaction, or you can also say that sunlight. So this is actually a photochemical reaction. What is a photochemical reaction? That needs UV light or sunlight to take place. So chlorination of alkene is actually a photochemical reaction. So you get chlorination. It can also be, if it is bromination of alkane, then still you need the UV light, okay? So chlorination of alkane is a substitution reaction. Why substitution reaction? Because one hydrogen has been replaced by other chlorine, right? So it is a substitution reaction. Hydrogen is replaced by the chlorine. So what does it mean? That chlorine has substituted the hydrogen. So that's why we also call it substitution reaction, that one atom has replaced another atom. So what are the conditions? Only we need a UV light. You need to remember that one. Now another chemical reaction, number 9, oxidation of alcohol or ethanol. So this is also from the organic chemistry. Conditions, what are the conditions that are required for the oxidation of alcohol? So for the oxidation of the alcohol, if you see here, acidified potassium dichromate or acidified potassium magnate, these are the two important catalysts. You can use any one of those catalysts, or you can memorize them. These are the two catalysts that are needed, and heat under reflux. You cannot provide the heat directly. You also have to provide the heat under reflux method. Reflux means that you have to do the condensation method also, because for alcohol, all the alcohol will evaporate in the presence of the heat, okay? So that's why we use the refluxing method, so that we can get back our product. So it is used for the production of ethanoic acid, okay? So oxidation of alcohol will usually produce what? Carboxylic acid. So carboxylic acid are produced from alcohol through the process of oxidation. And for the oxidation, we will just use acidified potassium dichromate that will provide the oxygen. Okay, it will provide the oxygen atom, and then it will be converted into ethanoic acid, we can see, and also in water. So you will get two products. The 10th one is esterification, alcohol and carboxylic acid reaction. Whenever alcohol and carboxylic acid react, you will get what? You will get an ester and a water molecule. So this reaction is usually reversible, and to avoid this reversible reactions, concentrated sulfuric acid is added as a catalyst. So this concentrated sulfuric acid will help the reaction to be only in the forward direction. It will not allow it to move back again into the reactants. That's why we use we use sulfuric acid, concentrated sulfuric acid as a catalyst if you want the production of ester, because this is a reversible reaction. So to avoid the reversible reaction, you have to add concentrated sulfuric acid. So these are the 10 important chemical reaction that are present in your in your book. And